Here is a model for a tan function. We will be using y equals tan x plus pi over 4 as practice to graph a tan function. Because pi over 4 is being added to x, we know that the graph is moving left pi over 4 units. That leads us to know that we can use x minus pi over 4 as a model, and because it's not affecting y, we leave y alone. Above are the values of the parent graph of tan x. There are 2 vertical asymptotes and 3 points in between to represent the tan graph. Using x minus pi over 4, y as a guide, we can plug negative pi over 2 in for x. Negative pi over 2 is also negative 2 pi over 4 minus pi over 4. This gives us x equals negative 3 pi over 4. This is our first asymptote. Next, we use negative pi over 4 in for x. So negative pi over 4 minus pi over 4 gives us negative pi over 2. And we just plug in the same y value. There's our first intermediate point. Same thing goes for the x-intercept. We take the x value and plug it in for x. So we know 0 minus pi over 4 will give us a negative pi over 4. And we use the same y value. There is our x-intercept. For our second intermediate point, we do the exact same thing. Pi over 4 minus pi over 4 gives us 0. Same y value. There's our second intermediate point. For our other vertical asymptote, we do the exact same thing. We plug pi over 2 in for x. So pi over 2 is also 2 pi over 4 minus pi over 4. This gives us x equals pi over 4. I have drawn a coordinate plane here going by increments of pi over 4 because it will be easier to graph our points. On the y-axis, I've just gone by increments of 1. We will first begin with our vertical asymptote. X equals negative 3 pi over 4. So we go to negative 3 pi over 4 and draw a dashed line representing the vertical asymptote. We will then go to our first intermediate point, negative pi over 2, negative 1. Our x-intercept, negative pi over 4, 0. Our next intermediate point, 0, 1. And our final vertical asymptote, x equals pi over 4, and another dashed line. Now that we have our points down, we use our asymptotes as a guide. It may look like a straight line, but because of the asymptotes, it never touches the vertical asymptote. It looks something like this. The definition of amplitude is half the distance between the maximum and minimum values. Because a tangent graph does not have a maximum or minimum values, the amplitude is none. The period of a tangent graph is pi over the absolute value of b. In this case, b is 1. So our period is pi. The phase shift of this graph can be defined by negative c over the absolute value of b. C is negative pi over 4 have replicated the period twice. Because our period, as we determined earlier, is pi, each value moves pi either left or right. In this case, I drew them all to the right. So our vertical asymptote moved a pi over to the right each time. Same with our values. This is an example of a tangent graph.
This is the secant graph, also known as the inverse of a cosine graph. A here represents vertical compression and expansion. B represents horizontal compression and expansion. C is left to right shift, and D is up and down shift. This is our equation we're using. Y equals 1/2 times the secant of 3x. We know 1/2 shows a vertical compression. All right, BC for vertical compression of 1/2. Since we have a vertical compression of 1/2, we know our y has to be multiplied by 1/2. And as we see by the 3x right here, we know we have a horizontal compression of 3. So we have to divide the x by 3.
As a reminder, the amplitude is half the distance between the maximum and minimum values. As you will see in a second, a secant graph has no maximum or minimum values. So the amplitude is none. The period can be found by using 2 pi over the absolute value of b. As we refer to this, our b is 3. So 2 pi over the absolute value of 3. 2 pi over 3. To find our phase shift, we use negative c over the absolute value of b. C in this case is, we don't have a c, so it would just be 0 over absolute value of 3, which is no solution.
Now to put all our information in a table, we use our x over 3 and 1/2 times y. So we see our first vertical asymptote is negative pi over 2. So up here, we do negative pi over 2 times 1 over 3, and that gives us negative pi over 6. Now we move over here to our first relative maximum. We take the 0, put it in for x, and we get 0. Then we take the 1, and we plug it in for y, and we get 1/2. Our next vertical asymptote is pi over 2. So we come over here and do pi over 2 times 1 over 3 equals pi over 6. Our relative minimum, we take pi, put it in for x, and we get pi over 3. And we take negative 1, put it in for y, we get negative 1/2. Lastly, we do our last vertical asymptote, which is 3 pi over 2, and we put that in for x over here. And we do 3 pi over 2 times 1 over 3 equals pi over 2. To graph our points on our secant table, we start with our first vertical asymptote. We plug negative pi over 2 in for x up here, so it's negative pi over 2 times 1 over 3, and we get negative pi over 6. Next, we use our relative minimum, and we plug 0 in for x up here, divide by 3, and we get 0. Then we plug 1 in for y, and we get 1/2. Next, we use our second vertical asymptote, pi over 2, and we plug that in for x up here and divide it by 3. So it's pi over 2 times 1 over 3 equals pi over 6. Next, our relative maximum, we plug in pi for x, divide it by 3, we get pi over 3. Then we plug -1 in for y, and we get -1/2. Lastly, our third vertical asymptote, we take 3 pi over 2 and plug it in for x and divide it by 3. So it's 3 pi over 2 times 1 over 3 equals 3 pi over 6, which reduces to pi over 2. For our graph, we decided to use an interval of pi over 6 to minimize our effort from this graph. So pi over 6, 2 times pi over 6, 3 times pi over 6, etc. On our y-axis, we went by intervals of 1/2 and -1/2.
Using our points that we found, we can use our vertical asymptotes, negative pi over 6, to draw a dashed line representing our asymptote. Then we take our relative minimum, 0, 1/2, and plot it on the coordinate plane. We then go to our next vertical asymptote, pi over 6. We draw another vertical dashed line at pi over 6. Our relative maximum, pi over 3, -1/2. We plot that on the coordinate plane as well. Our final vertical asymptote, pi over 2, is also graphed using a dashed line. This is the structure of the first period. We then go to draw our relative minimum and draw a parabola opening upwards using our asymptotes as guides. We follow the same method for our relative maximum. Here is the final outcome of the first period. Since we determined the length of our period is 2 pi over 3, we can determine the vertical asymptotes for the succeeding periods. Pi over 2 plus 2 pi over 3 gives us 5 pi over 6. 3 here, 2 pi over 3 to here. And if you want, you can go 2 pi over 3 on this side. Now we go by 2 pi over 3 for our points. We go 2 pi over 3 to pi -1/2. Draw our parabola. And go up here to 2 pi over 3 +1/2. Draw the parabola. There's 2 full periods. You can also add some on this side if you would like. Take over here our point, go 2 pi over 3. And there you have it. This is our secant graph using the formula 1/2 secant 3x.